Before we begin, slow down. Let your shoulders loosen. Let your breathing settle into something steady. Grab a coffee, tea, or whatever makes it easier to stop scrolling and start listening. Because this story isn't about something you can see. It's about something you've never heard, but that has been ringing out across the universe for nearly 14 billion years. And before we go any further, if you enjoy calm, curiosity-driven videos that blend science, scale, and slightly unsettling ideas, take a moment to like this video, share it with someone who enjoys late-night thinking, and leave a comment at the end with your interpretation. Now, here's a strange question. Does the universe make sound? Your first instinct is probably no. Sound needs air. Space is a vacuum. No air, no sound. Case closed. Except that answer turns out to be wrong. Not metaphorically wrong, physically wrong. Because while sound as we experience it needs a medium like air, vibrations themselves do not, and the universe is full of vibrations. Let's start with something familiar. When you strike a tuning fork, it vibrates. Those vibrations travel through air. Your ears detect them. Your brain interprets them as sound. Now imagine removing the air. The tuning fork still vibrates. You just can't hear it. The vibration didn't disappear. Only your access to it did. That distinction matters because the universe vibrates constantly. And in some places, we've learned how to listen. Let's go to the largest objects in existence, galaxy clusters. Massive collections of thousands of galaxies bound together by gravity and surrounded by enormous clouds of superheated gas. This gas is not empty. It's thin, but it's there. And in 2003, astronomers studying the Perseus cluster noticed something strange. Ripples, concentric waves moving through the gas. At first, they looked like shock fronts from explosions, but when scientists analyzed them more carefully, they realized something unsettling. These ripples were pressure waves, sound waves, on a cosmic scale, generated by a supermassive black hole at the cluster's center. Now, let's pause and appreciate how absurd that sentence is. A black hole producing sound loud enough to ripple gas across hundreds of thousands of light years. When researchers converted those pressure waves into audible frequencies, they discovered something even stranger. The pitch was extremely low, a B flat, about 57 octaves below middle C. So low that no human ear could ever hear it. But it's real. The universe is humming. And that's just one example. Because vibrations aren't limited to gas, they exist in space-time itself. In 2015, scientists detected something extraordinary: gravitational waves. Tiny ripples in space-time caused by the collision of massive objects, black holes and neutron stars. These waves passed through Earth, through your body, through this screen, without you noticing. But detectors noticed. And when scientists translated those signals into sound, we heard chirps, rising tones, a brief whoop from two black holes spiraling together and merging. That sound wasn't added for drama, it was data. Space-time ringing like a bell. Now think about what that implies. Space isn't silent, it's elastic. It stretches, it compresses, it vibrates, which means the universe is less like an empty void and more like an instrument, and every massive event plays it. But the most unsettling sound the universe ever made didn't come from black holes. It came from the beginning, the Big Bang. Now, this is where language gets tricky. The Big Bang wasn't an explosion in space, it was an expansion of space. So it didn't make sound the way explosions do. But it did leave behind something else: pressure waves. In the early universe, matter and radiation were tightly coupled in a hot, dense plasma. Tiny fluctuations in density created oscillations, compression and rarefaction, the same basic mechanics as sound. These are called baryon acoustic oscillations, and they still exist, frozen into the large-scale structure of the universe. Galaxies today are slightly more likely to be separated by a specific distance, about 500 million light-years, because of sound waves that rippled through the universe when it was only 380,000 years old. In other words, the distribution of galaxies is shaped by ancient sound. The universe remembers its own vibration. And here's the part that makes this unsettling. Those early sound waves stopped being sound once the universe cooled enough for atoms to form, but the pattern remained, like a fossil, a record of a noise that no one was there to hear. Now let's bring this closer to home. The sun. It looks calm, steady, unchanging, but it's not. The sun rings, literally. It oscillates. Its surface rises and falls in complex patterns driven by sound waves trapped inside it. This field of study is called helioseismology. By listening to the sun's vibrations, scientists can map its interior, just like geologists use earthquakes to study Earth. The sun has thousands of resonant modes, different pitches, different rhythms, a star singing to itself. And stars aren't unique. Neutron stars vibrate, white dwarfs vibrate, even planets vibrate. Earth does. After major earthquakes, the entire planet rings for days, at frequencies too low to hear, but measurable. So here's the emerging picture. Matter vibrates, gas vibrates, stars vibrate, space-time vibrates. Vibration is not an exception, it's the rule. Which leads to a strange idea. Maybe sound isn't something added to the universe. Maybe it's fundamental. Now let's push this further. In quantum physics, particles are not little billiard balls. They are excitations of fields, vibrations. An electron is a vibration in the electron field. A photon is a vibration in the electromagnetic field. Which means at the deepest level, reality is not made of things. It's made of oscillations. Everything you see, touch, and are is a pattern of vibration. So when we say the universe makes sound, what we really mean is that the universe is sound, translated into matter. Now ask yourself this: if everything vibrates, why does anything feel solid? Because vibrations can lock together, resonate, stabilize, just like a chord on a guitar. Now here's the unsettling part. Resonance is selective. Some frequencies amplify, others cancel. Which means the structure of the universe depends on which vibrations persist. And that suggests a haunting idea. What if the universe we see is simply the stable resonance of a deeper chaos? The notes that didn't fade out. Now let's talk about silence. True silence is not the absence of sound. It's the absence of vibration. And according to physics, that state may not exist. Even at absolute zero, quantum fields still fluctuate. Zero-point energy. The universe never fully shuts up. Which brings us back to the opening question. Does the universe make sound? The answer is yes, just not for ears like ours. It hums in frequencies too low, too vast, too subtle. It sings in gravity, in radiation, in the spacing of galaxies,
and we're standing inside that music, unaware. Now, here's a final thought. Your brain is also an instrument. Neurons fire in rhythms, brain waves oscillate, thought itself has frequency, which means when you listen to the universe is also listening back. Not consciously, but physically, because you are part of the same vibrating system. So the next time you think of space as silent, remember this: silence is just sound you haven't learned to hear yet. If you enjoyed this video, make sure to like it, share it with someone who enjoys science and big questions, and leave a comment below. What do you think the universe would sound like if we could truly hear it? Because maybe the